Have you ever noticed that 3D printed resin objects usually come in just one color? That is because vat photopolymerization, the method behind most resin 3D printing, relies on a single vat of uniform resin. Switching materials mid-print is messy, slow, and not practical. But what if we could print objects with color gradients and patterns without ever changing the resin? That's exactly what researchers at the University of Wisconsin set out to achieve. Let's first understand how vat photopolymerization works. Vat photopolymerization is a type of additive manufacturing where a liquid photopolymer resin is cured layer by layer using light. In a bottom-up system, light passes through a transparent vat bottom, selectively curing resin at precise locations. A build platform lifts after each layer is cured, allowing fresh resin to flow in and the process to repeat. But how does the light cure the resin? Let's dive into chemistry behind it, specifically chain growth polymerization. This process requires three key steps: initiation, propagation, and termination. In initiation, an initiator, or photoinitiator in this case, such as acyl phosphide oxides and BAPO, absorbs light energy and then undergoes the dissociation and produces a pair of reactive radical species. These radicals initiate polymer growth by reacting with monomers. The common monomers used are acrylate-based resin, such as PEGDA and PMMA, as they are rapid curing resin and make them suitable for fast prototyping. And during propagation, the active chain end adds one monomer at a time, allowing the growth of the polymer chain. In termination, the chain growth stops, occurs through either combination or disproportionation. Combination is when two active chains couple together, and disproportionation involves hydrogen abstraction from one active chain to another, resulting in one saturated chain and an unsaturated chain. And let's use BAPO and PGDA as an example. BAPO effectively generates free radicals through cleavage of the bonds after exposure to light radiation. The radical adds to acrylate double bond of PGDA, and PGDA contains two acrylate groups, and this feature enables cross-linking, creating strong 3D polymer networks. And now you may now wonder, how is multicolor printing achieved in a single vat? Inspired by the acid-base titration, the team added two key components to their resin: a photoacid generator, PAG, and a pH-responsive dye. A photoacid generator, TAS, used in this case, is a molecule that releases protons when exposed to UV light, effectively lower the pH in localized region. A pH-sensitive dye changes color depending on the acidity around it, and for example, bromo crystal green transitions from blue to yellow as the environment becomes more acidic. And by mixing the PAGs and dyes into the resin, and by using visible light to cure the structure and 365 nanometer UV light to locally control acidity, the researchers is now able to control where and how much the pH shifts, and thus where and how the color changes. This approach allows vibrant color printing, showing great potentials in art, education, engineering, visualization, paving the way for a future where 3D printed objects are not only functional, but also vivid and artistic. And hope you like it, and thank you for your listening.